Hello, in this video we will learn how to run Python scripts, Python code from C#, from .NET 10 in this case, although it was sort of available in earlier versions as well, but certainly .NET 10 works quite well. We will take a look at how you set it up, how you run it. Our previous video on this channel was about running JavaScript from C# in a sort of almost the same way. Perhaps JavaScript is more straightforward and more containerized as such. This will require a bit more setup, but it's still relatively straightforward, and you can certainly run rather Python from C# with all the requirements of all the packages that are available in Python. So let's get to it. Let's see what we need. First of all, we need CSnakes.Runtime. This is the NuGet package that we need to use, and there's nothing else you need to do. There is this one original that's been deprecated. You want to use CSnakes.Runtime, right? This one, it's quite important not to forget, although it says deprecated, but still, when you search, you might find this. But this is the one you need to use. Now, before we go into it, we'll need a bit of something here. We have just a very simple, really, Python arrangement. We have compound interest calculation, which takes some parameters here, or arguments, whichever way you want to look at it. And the same goes for summary stats and some of these few other things. The idea is generally the same. It's just what you return and how you return it. But this is the script essentially that we will be running. It does require NumPys, right? Here we have it. So we need to sort of install it somehow. Now, in order to install it, we'll need a text for requirements. We could probably pass it in other ways, but this is the sort of best way to do it. See NumPy like that. In order for this file to be readable, you're gonna put it in the project, probably somewhere in your C# project, that is. And you need to declare it in the item group as additional files, right? This one, again, depending on your directory as well, and set it copied to output directory always, because otherwise it will get lost. It's not going to get to the output directory after compiling, and the program won't be able to access it. Now, to get started with this whole thing, we don't actually need this. We need just all these other parts. Some using statements, snakes, runtime, runtime.python, and a few injections for the C# side of things. Now, the way you set up, the way you register the service, you have WithPython, with home. The default thing, home is your directory that you're using. In this case is going to be the application directory. You could point it to somewhere else, of course, however you install your program, however you use it. Although if it's a web arrangement, you'll probably just use the current directory, which is the application directory. That's the only one probably will be available. Now, this part actually downloads and sort of installs redistribution for the Python running arrangement, the latest version. That's the NuGet package we use. The other one, virtual environment, it's quite self-explanatory. This, however, is very important with pip installer. So this will install all those Python packages. NumPy in this case might be something else. Again, it actually works. There are libraries in C# and .NET that allow you to run Python, but some of them prevent this installer, so it's not really that good, and some of them are sort of a bit out of date now. So this is kind of the best arrangement if you need to run this Python stuff from C#. So let's move on to the actual setup, sort of calculations and things that we have there. So we register a service, Python environment. We need that environment to be registered, and then we get the calculations. Now, this is the IPython environment as a sort of service, right, registered. So here we just have a console application, so we would do it this way, which would be injected in web pages or wherever you want to do it. Probably not web pages, but perhaps some controllers and things, some services where it would actually be used from. But we get the reference for the calculations, and this basically gets all the references that we have here. So compound interest, summary stats, you have those references as C# code. And as you can see right here, we have compound interest. And if you type, you'll see all the other stuff that we can access from it. Now, compound interest, it's a simple return type, double, balance, and we provide all the parameters here. They get passed through, and then we get the result. A very basic example, a very straightforward example, but all the other arrangements will work the same. Now, the biggest thing here, of course, there is a bit of setup and all of that, and sometimes it may run slower or very slow it may be as well, so you don't want to crash your C# application. So if you're doing some heavy work with that, perhaps you want to use a scheduler, perhaps you want to send those jobs to a separate server or separate sort of arrangement somewhere, right? For that, you might need schedulers. We have a few things in this channel. There's RabbitMQ, something quite interesting, perhaps related to that, some queuing arrangements. So take a look and explore. Videos are quite short, but we get to the point quite quickly. So we have compound interest, we have return, perfect, very simple. And again, the biggest problem, of course, just like running some C++ code from C#, you need to match those types. Of course, doubles, sure, decimals, doubles, integers, they're quite easy, right? But then we get to something like lists. Now, list can be returned as many things. So we have this read-only dictionary. Let's expand it actually like that so we can kind of hover on it. Of course, that doesn't work, but let's do it like this. Read-only dictionary. So it's not exactly dictionary, it's not exactly list, right? It's a read-only dictionary, a sort of more specific type that we get as return. If we go back into the Python, we essentially just have a list of floats, right? Float, again, matches decimal. So it's not exactly, or rather double, matches float. So it's not exactly double or decimal or whatever, or float. It doesn't exactly match, so we always have to think a bit, but that's sort of easier. Now with list, we now start to return all these different types and things. And the next one, quite interesting, is you can return as a Python object. So sort of a buffer for whatever you're getting. And the object will have a few options. It will have import and as enumerable, probably is going to use as enumerable. This is, let's see, we have here normalize, I believe here. So that's a list. Again, a list, it's just a different way to access the list as enumerable, and then it will loop here and write those values. Now, you could convert then norm at that point to list or to array, to whatever you want, right? The link still works. But the interesting thing here, we have the return here as enumerable, but from Python, we also have the same type here, the stats, right? It's just a list from Python. So you can make it work like that and match these a bit. And of course, as far as providing the parameters, here we have sample. It's sort of custom type, if you will, or somewhat more custom. It's a list, not even a custom object. But once you get to some class objects and things like that, it can get a bit more troublesome. But always watch out for these conversions. That's the most difficult part here. It's not the setup. The setup is kind of tricky, but with the setup, the most important thing is to not forget to include all these things in requirements.txt, and of course include the actual requirements.txt file as well. And we also right here include calculations, the Python, right? Now that may be downloaded from somewhere else, it may be a different location, but essentially we do want to provide that from the directory here, right? So you kind of find it all in one place. And with that said, we will conclude this video.